Okay, question 2. A dishwasher has a mean life expectancy of 12 years with a standard deviation of 1.25 years. Assume the life of a dishwasher is normally distributed. So for A, state the random variable. What are they measuring? They're measuring the life expectancy of a dishwasher. For part B, find the probability that a dishwasher will last more than 15 years. So I've got a normal distribution. The center is at 12. The standard deviation is 1.25. And we want to be out here at 15. So it says more than 15. So we're interested in this region. So we're going to do our z-score. So that's going to be 15 minus 12 divided by 1.25. So it's 3 over 1.25. which is 2.4. So there you can see that it's very unlikely that we're going to last longer than 15 years, right? So we're going to go distribution, normal CDF, from 2.4 up to infinity. And we get 0.008. So the probability that our life expectancy will be greater than or equal to 15 is approximately 0.008 or 0.8%. Find the probability the dishwasher will last less than 6 years. So again, mean of 12. 6 is going to be way down here. And so we're interested in less than 6, so that little region there. So our z-score is going to be 6 minus 12 divided by 1.25. So this is negative 6 over 1.25, which is negative 4.8. So it's nearly impossible for it to only last 6 years or less. So let's do our z-score for that. We'll do distribution, normal CDF, from from negative infinity now, right? Up to negative 4.8. And we get 7.9 times 10 to the negative 7th. So the probability that our x will be less than or equal to 6 is approximately 0. That's so incredibly tiny, we can just say that that's essentially 0. If you insist, we could go 0.0000079. Let's see, 1, 2, 3, 4, 5, 6, 7. Yep. So very, very unlikely. Excuse me. That it would only last up to 6 years. D. Find the probability a dishwasher will last between 8 and 10 years. So then, again, we're going to go, here's the mean of 12. Standard deviation is 1.25. Between 8 and 10, someplace down here, we're interested in this region. So I'm not going to find the z-scores for this one. We can just let the calculator do all the work. So we're going to go from 8 to 10 with a mean of 12 and a standard deviation of 1.25, and we get 0.054. So this region is 0.054. So therefore the probability that our x is greater than 8 or less than 10 is approximately 5.4%. For E, if you found a dishwasher that lasted less than 6 years, would you think that you had a problem with the manufacturing process? Why or why not? Well, if we found a dishwasher that lasted less than 6 years, then we have some evidence that perhaps our process isn't working as we expected, because this is so incredibly unlikely to have happened that our process could in fact be broken. And so what we're essentially saying here is, if the mean really is 12, if the life expectancy really is 12 and the standard deviation really is 1.25 years, then this should not have taken place. And yet it did take place. Therefore, our mean probably isn't 12. So the answer is yes. Such an unlikely occurrence should not happened. Therefore, the mean is probably not 12. So we have some evidence that suggests that the mean life expectancy really isn't 12 because that is such an unusual event. And F, manufacturer of dishwashers only wants to replace free of charge 5% of all dishwashers. How long should the manufacturer make the warranty period? So he's interested in, or she's interested in, here's 5%. So we want this area down here to be 5%. So we're looking for what age is going to be the 5th percentile. So remember, that'll be inverse normal again. So we'll go distribution, inverse normal. The area is 0.05 because it's the 5th percentile. The mean is 12 years. The standard deviation is 1.25 years. And we get 9.94. So therefore, X is approximately 9.94 years. And they wouldn't do it for 9.94. They'd really say X is therefore going to be 10 years. And that's it.